Betelgeuse is a red giant star. If you put it where the sun is, it would grow out to Jupiter's enormous orbit, extremely unstable and about to explode. One of the biggest bursts is an explosion of radioactivity throughout the entire universe, generating more energy than 1 billion suns. Are you prepared for what is about to happen? Betelgeuse, a massive red supergiant, one of the closest supergiant stars to Earth, has recently undergone a remarkable dimming that has captured attention and evoked mixed feelings globally. This dimming has led to speculation among astronomers and the public about the potential consequences. This, according to some scientists, unusual behavior may signal the beginning of a supernova, a cataclysmic event that occurs when a star exhausts its nuclear fuel and succumbs to its own weight, leading to a tremendous explosion. Such an event raises concerns not only among the scientific community, but also among the general public, as it inquires about the impact that could have on our own planet. Betelgeuse is a well-known star in Orion, a constellation that can be easily recognized due to its distinctive appearance in the night sky, recognizable form, and bright stars. Referred to as Alpha Orionis, it holds the name of the largest and brightest star in this grouping. Recent data collected by NASA's Hubble Space Telescope, along with observations from other observatories, has shown that Betelgeuse experienced a significant mass ejection in 2009. This behavior is unprecedented for a star of its type and has attracted the attention of astronomers worldwide. While coronal mass ejections are prevalent in our very own sun, the singular event depicted in Betelgeuse adds a fascinating dimension to our understanding of stellar life cycles and the dynamics of enormous stars. The distance to Betelgeuse remains a topic of controversy among astronomers. Estimates suggest it is farther away, while others indicate it could be as close as 724 light-years from Earth. Determining the distances accurately to Betelgeuse-like red supergiant stars is a difficult problem because of their immense distances and peculiar characteristics that set Betelgeuse apart. One of the brightest stars that can be seen in our night sky, boasting a luminosity approximately 100,000 times greater than that of the sun. However, this incredible brightness comes with a significant cost. Betelgeuse consumes its nuclear fuel at a rapid pace that hastens the inevitable end to its glorious existence. Eventually, the star will exhaust its fuel supply, leading to a dramatic disintegration under its own gravitational pull, potentially resulting in an explosion caused by a supernova that could give birth to a neutron star or even a black hole. Should our existing astronomical theories hold true, this raises an important question: does Betelgeuse pose a threat to Earth? If a supernova were to take place within a few tens of light-years away from our planet, the consequences could be devastating. The explosion of a supernova can release an extraordinary amount of light, potentially rivaling that of an entire galaxy. Consequently, if Betelgeuse is not too far away, such as Alpha Centauri, a star, the effects of its supernova could be profound and far-reaching. Remarkably, since the most recent supernova that we saw in our galaxy in 1604, humanity has yet to witness such an event locally. However, a notable supernova did occur in 1987 in the Large Magellanic Cloud, with a location 169,000 light-years away. While that event had significant effects, it posed no direct threat to Earth. That serves as an illustration of the scale and potential impact of such occurrences in the heavens and Earth. A danger zone surrounding a typical supernova is fascinating and may have grave implications for Earth's life if a supernova were to strike close by. Nevertheless, it's essential to understand that in the vast cosmic surroundings, supernovae are relatively insignificant events in comparison to gamma-ray bursts, which are incomprehensibly stronger and a different kind of threat. Supernovae can have devastating effects, capable of obliterating worlds, inundating biospheres with lethal radiation. For example, a specific kind of supernova can result in the destruction of a planet's ozone layer, making it susceptible to the forceful radiation of the universe long after the explosion has taken place. This danger was highlighted in a recent study that introduced new potential dangers associated with massive stars that end their lives in a spectacular fashion. When giant stars explode in a supernova, they can reach some of the highest luminosities known in the universe. In fact, the brilliance of a single supernova can outshine the combined brightness of hundreds of billions of stars. This raises the issue of exactly what the implications would be if Betelgeuse were to experience such an explosion. If a supernova were to occur, Betelgeuse would become the second brightest object in our sky after the Sun. Remarkably, despite the distance separating it from us, Betelgeuse, which shines more brightly than a full moon, would become visible during daylight hours. The sheer magnitude of the resulting explosion, in a display so dazzling that shadows would be cast even in complete darkness, would be both inspiring and terrifying, displaying the unadulterated power of cosmic events. While the visible light a supernova produces is remarkable, it is only a fraction of the total energy released. During such an event, although high levels of visible light can pose risks, such as temporary blindness, the greater concern is the high level of energy radiation emitted alongside the visible light. This radiation, typically manifesting as gamma and X-ray radiation, can have far-reaching consequences. One of the most significant dangers posed by this high-energy radiation is its ability to stimulate the loss of oxygen from the ozone layer that shields our planet from harmful solar radiation. Without a robust ozone layer, life on Earth's surface would be exposed to intense ultraviolet radiation from the sun, possibly resulting in mass extinction events. In the immediate aftermath of a supernova, a variety of threats emerge over time, particularly in the initial explosion. The intense radiation released poses immediate risks. However, as time passes, cosmic rays, subatomic particles propelled to near-light speeds, begin to infiltrate the solar system. These cosmic rays can shatter ozone layers and blanket Earth's surface with deadly radiation, compounding the dangers brought on by the initial explosion. Additionally, cosmic rays carry with them a sizable percentage of the total energy released by the supernova, and their long-term effects can linger for centuries. There is evidence suggesting that Earth may have been affected by such events in the past. For instance, elevated levels of iron-60, a radioactive isotope created in supernovae, have been discovered in lunar regolith and ocean floor sediments, indicating that Earth may have been impacted by supernova ejecta in relatively recent geological history, perhaps within the last few million years. Astronomers have already concluded that no candidates for close supernovae that pose an immediate threat to life on Earth exist at the moment, based on our understanding of the dangers associated with gamma rays and cosmic rays. However, ongoing research has uncovered additional potential risks associated with specific types of supernovae. These supernovae can emit long-range deadly radiation that poses a greater danger to planets like ours. The mechanism behind this involves a star close to the end of its lifespan, surrounded by a substantial disk of material. When the supernova occurs, a shock wave is generated, striking this disk and resulting in its extreme heating. As a consequence, the disk releases a significant amount of X-rays with high-energy radiation that can travel the longest distances across space. Luminous X-ray supernovae have the potential to deplete a planet's ozone layer by as much as 50%, creating conditions that might lead to an extinction event within approximately 150 light-years across. Fortunately, no candidate X-ray supernovae have been identified in close proximity to Earth. However, this research has led to a new understanding of the galactic habitable zone, the region within galaxies where conditions are favorable for life. The findings suggest that this habitable zone may be subject to additional constraints. Specifically, the outer regions of a galaxy do not have sufficient star formation activity to produce the elements necessary for the formation of rocky planets. Meanwhile, the inner regions, where stars form and die quickly, pose their own dangers. Frequent supernova explosions in these areas can irradiate the surrounding space, increasing the risks for any potential life that might exist there. New research indicates that the inner boundary of the galactic habitable zone is likely located farther from the galactic core than previously thought, changing our perception of where life could potentially thrive. So what will an explosion, like Betelgeuse's, look like from Earth? While it's reassuring that Earth's biospheres will likely remain unaffected, the spectacle itself will be impossible to ignore. According to experts, Betelgeuse will continue to shine brightly for more than 3 months following its explosion, reaching a luminosity comparable to half that of a full moon, 9 times less bright than a full moon. In essence, it will manifest as a bright star in the sky that serves as a beacon, visible even during the day. Its striking brightness will captivate anyone who gazes upward, casting nighttime shadows. This cosmic event will undoubtedly be a source of fascination for everyone on the planet, as the supernova remains visible to the naked eye for several years, gradually diminishing. As scientists supernovae continue to form new stars. Millions of years have passed since the original explosion, showcasing the dynamic nature of the universe. Another fascinating aspect of supernova research is their role as indicators of cosmic distance. Type Ia supernovae are used by astronomers, explosions of white dwarf stars that reach a consistent peak brightness, as standard candles for measuring distances in the entire universe. This method substantially contributed to our understanding of cosmic expansion and the seriousness of the dark energy discovery, a force that causes the universe's expansion to accelerate. Furthermore, supernova research can provide insights into the possibility of habitability on exoplanets. Scientists are looking into how the radiation released during these stellar explosions might affect planets orbiting nearby stars, potentially influencing their atmospheres and life's viability. This study focuses on the significance of comprehending the surrounding conditions that govern life across the cosmos. The potential to observe a nearby supernova raises intriguing questions about cultural responses to such cosmic events. Throughout history, myths and legends have been shaped by supernovae and creative expressions. The flurry of a star is more than just a scientific phenomenon. It becomes a powerful symbol in human culture, representing transformation, destruction, and rebirth. In many cultures, the night sky's bright new stars have been interpreted as a message or omen from the universe. Advances in technology have revolutionized our ability to identify and study supernovae. Space telescopes with cutting-edge sensors can capture detailed images and spectra of these events that demonstrate their composition and behavior. Ground-based observations are also necessary, allowing astronomers to monitor transient events, swiftly respond to observations, and gather data in real time. The study of supernovae lies ahead with exciting options, as brand new telescopes and instruments are developed, such as the James Webb Space Telescope. Scientists will acquire unprecedented understanding of the star's cycles of life and the dynamics of their explosive deaths. These observations could lead to breakthroughs in our perception of stellar evolution and the fundamental processes that are responsible for shaping our universe. Investigation into Betelgeuse and its impending supernova event serves as a gateway to more comprehensive discussions about stellar evolution, cosmic recycling, and the impact of these phenomena on life and culture. The study of such massive stars makes us appreciate the often violent and intricate processes that direct the universe, illuminating our place in the vast and ever-changing universe. Supernovae also contribute significantly by marking their place in the cosmic timeline, the end of a star's life, and the subsequent formation of diverse celestial structures. The leftovers have the potential to develop into nebulae, which are vast clouds of gas and dust that serve as fertile grounds for new star formation. These areas contain intricate chemistry that contributes to the emergence of organic molecules, which are the precursors to life. Moreover, the shock waves brought on by supernova explosions can trigger star formation in nearby molecular clouds. This process, known as triggered star formation, showcases the interconnectedness of stellar phenomena and demonstrates how a single explosive event can start the birth of new stars and planetary systems. This demonstrates how important supernovae are, not just as endpoints but as catalysts for future cosmic evolution in the vast scheme of the universe. Additionally, supernovae contribute to the dispersion of heavy elements all over the cosmos. As these elements spread across space, they enrich the material from which future stars and planets are formed, influencing the chemical diversity necessary for life in the end. This cosmic recycling highlights the importance of understanding supernovae in the broader context of astrophysics and the origins of the elements that make up our very own planet and, in turn, life itself.